2022.
Apparently not. Okay, so welcome all. It's nice to see you. I'm making many faces behind my black screen right here. You know, before we get started, something I'd just like to have a chat about. We can either do this today or next week or in 2 weeks from now. Just have a thought on things that we would like as a community to try to tackle with SimPEG in the coming year, like things we'd like to see added, things we'd want, areas that we kind of want to focus on. Just looking forward to the new year to see where people are at, what they're hoping to do with SimPEG. I think it'd be nice to kind of like, take this role and kind of focus, see what we're interested in. Obviously, it's what people want to tackle. They're going to tackle that. Like, just to have an idea of where people are, though. So just kind of start thinking about that. I'm assuming we don't have too many quick reports over the last 2 weeks. Myself, I spent the last few weeks with family down in the States. I don't think we caught COVID because we were let back into Canada yesterday. So it's all good though. I have an article going through with the copy editing status for geophysics that should be coming out soon. So
what's that one about, Joe?
It is a separate project that I had. This paper has been in revisions, like being going through the whole process for about 1.5 years now.
Jeez.
Yeah, it is on like combining gravity and gravity gradiometry data, just a little bit more rigorous than essentially almost every other piece of work that has ever been published about it. It's just more rigorous of an approach to it, about how to adequately combine them, thought processes, just kind of a general steps you should take when you want to combine them and why and what they can do together. So
cool. Looking forward to it.
I say it was my mini master's project that I did within my PhD. Like, it had nothing to do with any of my PhD topics. It just essentially it would have been a master's project on its own, but it was just a neat, fun little thing to do off to the side. So that'll be hopefully coming out in geophysics soon, and I should be able to share it shortly. But it's a big mix of random little things. There's a little bit about me building models with Minecraft in it for making tests.
Nice.
So it's kind of interesting. It's like, oh man, I got to cite Minecraft in a geophysics article.
Hey, are we going to be able to expand that, do you think, to mag and mag radiometry?
Oh yeah, definitely. It's
definitely,
just
right? Yeah.
It's one of the things where it's like I don't. It's about, like, we do have to actually properly weight the two different types of data sets, or else they just don't fit. They don't fit, and you kind of lose out on the benefits of combining them if you don't properly weight each of them individually.
And then your strategy, you usually have a strategy to do it. That's great.
Yep.
Super. Yeah, that would be super useful.
Yeah.
Let us know when it's out.
Will do. Other than that, break was nice. It's all family that I haven't seen in 2 years.
You missed the snow?
I got my own snow down there in Colorado. I was up in the
you
mountains on Christmas Eve, and we got like a foot of snow on Christmas Eve. It was beautiful. But there's still snow coming down here as of yesterday, right?
Yeah, it's doesn't stick very long. It's pretty wet.
Okay. Oh, Lindsay, I see you're typing as we speak.
Quick note, I'm sure most people saw this here, but I'll just point it out. If you know anybody who's interested in a postdoc looking at EM for UXO primarily, so both sort of combining inversion as well as machine learning, please put them in touch. But EM kind of being the biggest thing. If they've never worked with UXO, that's fine. But if they worked with EM or neural networks, that would be great.
It's did you create once a channel, or will you create a channel once you have a PhD? I think we just had last November the master thesis projects, which are usually coming from industry. And I think this year there were at least 5 projects in this topic from 3 or 4 different companies, and we have a couple of master students working on that. So
Okay,
it's
excellent.
kind of nice to have like a channel and exchange some ideas. And
Sure.
it is a particularly hot topic here in the Netherlands for offshore windmills from old bombs from the Second World War, which is kind of an interesting topic. So very shallow marine 0 to 10 meters, let's say, water depth with very shallow bombs.
Yeah, for sure. Let's do that. That would be great. And I'd be super interested if you could point me to some of the recent work. I did see the master's thesis that came out, but if there's other things, that would be awesome.
The new ones will start in March to August. So yeah, it's something to start in the future.
If I may ask, Lens, you can not answer if you can, but is there a sponsoring company? Because I know that ocean floor is all over that stuff, right? What Dieter was talking about, yeah.
So it's a funded proposal through CERDIP, which is, I forget actually what that stands for. It's a combination of the Department of Energy, the EPA, and the Department of Defense.
Oh, so US, okay.
So
yeah.
it's US, but we're partnering with Black Tusk. So Black Tusk is also part of the funded group. And so they're providing data and sort of the system specs and helping kind of motivate and shape the project. So
cool.
Yeah, so they're all involved.
Nice. All right.
Hey. Any other quick reports?
Yeah, maybe I have what I wrote. It was pure accidents, and I stumbled on this read the docs link, and I thought even it took me a while to realize, shit, that's very old documentation, and I know SimPEG. So I thought if another user stumbles up in these old documentation, it might be bad. So I don't know who has the login credentials for read the docs, if that can just be removed or if you have to update something. Or
I remember we encountered the same thing with the GIF tools, with the manuals, right? People can still hit the old versions of the other read the docs, even if we completely pull the plug on them. And yeah, I don't know.
I think you can delete old versions if you still have the login credentials. You can actually manually remove them, but yeah.
By memory, I think we had like no traces of it, and Google could still pull them out somehow. So I'm not. Yeah, I don't know.
You're finding them in because I think the URL was the same and the page was almost like saved in some kind of cache. Because I think I asked you to do a full refresh. Like for me, it was a Control F5, and I think you did it, and it loaded the latest one. It loaded it clean.
No, in my case, not, because I'm one of those crazy guys. If I close my browsers, it's empty.
It clears it all.
There is no cache, there's no history. If I start up, it's like a fresh browser. So it cannot be that.
Yeah, it's still live. That's something I should be able to delete. I will just ping Rowan because he also set that up and see if he has any concerns. But yeah, it is still something that you can absolutely land on, which is a problem.
What is the oldest version? Like, what is the oldest, the newest version on Read the Docs? Do you have any idea? Because it says latest, but
ages
it's
ago.
Probably
it hasn't built in probably
years.
over a year. So
yeah.
It's old.
Yes.
Do you remember how you got to that? How you got to there, Dieter? Like it was just a search result on Google?
I searched for a function of SimPEG, and it was basically coming up the RT. Yeah, I don't know. I don't remember what it was. I Googled something. Not even sure if it was something specific, discretize or SimPEG, but this SimPEG RTD showed up. Yeah. But I linked it now, so it's. I'll have a look.
Yeah, so it is still live. Like there is a live link from Read the Docs.
So
to kill it.
It looks like there's a way, like the Read the Docs link does kind of forward to where the docs might be. Because it forwards to like docs, SimPEG, XYZ, and latest. Right now they're just all on, like we haven't been keeping around older versions of the documentation.
But the URL, if you go to docs.simpeg.xyz, shouldn't have the EN latest. So I think we've actually got wires here.
The forwarding actually works in the other direction. You can have GitHub pages and then have like your GitHub pages linking to the reader docs. And I think that's what happened for some time for SimPEG, no?
I think we
Maybe
have
not.
too many things pointing at the same URL, because read the docs right now, you're right, we are pointing to the simpeg.xyz site, and we're doing that with GitHub. And so the fact that you have this /en/latest grabs read the docs, whereas the other one grabs, if you leave that off, will grab GitHub. So that's super confusing.
And it's still searchable, I guess. Google cleaned it up. So it's not good.
It's been indexed.
Yeah. It's in the graph. Okay, I can go next. I did spend 2 or 3 days working on the refactoring of the regularization, what we're starting to talk about. Made some good progress. Now I'm kind of working down the unit test to make sure they're still passing, and then adding like, you know, deprecation warnings for all the name changes. I think there's like so much stuff in there that we should probably have like a quick overview together for the people who want to do a review, because it's obviously it's a big module, the regularization, so we should probably agree or disagree on changes. And then other thing, I flagged for you, Joe, right? On PyDeso, just before the break, we were hoping to do a release, and then all our inversion unit tests starting to fail because on Windows only, because of changes that happened on MKL. So right now I have to pin the version of MKL for Windows to still be able to run PyDeso solver. But anyway,
I
put
wonder
an
if
issue on
it's
PyDeso.
yeah, no worries. I wonder if it's an issue of like it needs to be pinned, like the version number needs to be pinned on a CondaForge.
Correct.
I want, as in like it needs to be pinned to a compatible version, and it has to be rebuilt. I wonder if it needs to be rebuilt for each different version of MKL.
I see.
Like, so, because sometimes like you can do this thing, you can pin compatible for NumPy, and it'll create different pre-built things for different packages of NumPy if it's needed.
Right.
So I'm curious if it's that.
I reran it, and if NumPy is, if I pin MKL to like the right version that works, but NumPy is ahead, is like the latest, then it still doesn't work. So it needs to be NumPy a specific version, and then PyMKL a specific version. I'm guessing we're using NumPy to compile the C code, right? Still, so.
Yeah, I'm curious. I'll have to check it out and see if it, like if it's an issue of just compiling against that version, or that it's something that I need to change on how it's built on CondaForge.
Yeah. So anyway, it's good that our unit tests are heading out. So yeah, Dieter, go for it.
No, just if it's just installing SimPEG at the moment, because EMPyMod is a dependency, and through this number cannot yet handle the newest NumPy. But that will come out in a day or two. That's number 055.
Yeah, it's funny because I had, if for some combination, I had a crash on EMPyMod for Python 3.9 on Linux only. Man, it's getting so complicated. But
yeah, that should be solved soon.
okay. Good to know. So you already know about it. That's good.
And NumPy is not yet ready for Python 3.10 either, but that's also a question of days. Yeah, they usually have to catch up. And I think NumPy had quite a lot of changes to bring in this new array interface.
Okay.
So I guess the last few NumPy releases were quite bumpy.
Right. Anyway, that's it from me.
see. Any Sagi, John, Devin? Anything over the break?
I mean, I don't have anything else that's too much SimPEG related, but lately I've been working on a lot of UTEM data. So this is like a large inductive loop source, and the idea is you got sort of a triangular waveform, and you're measuring dB/dt, but it's equivalent to measuring the B field for a step. So it's kind of an interesting setup, because to invert these data, you have basically data collected during the on time. And so looking ahead, there's, I don't think there's a well-established strategy for inverting those data and dealing with kind of the same issues we have when we do frequency domain EM, where we have to account for a primary field. So it's kind of a fun project. I got sent a data set to make a comprehensive workflow. There's tons of magnetic effects. There's all sorts of fun business. So yeah, when I write this up, but it's going to be interesting to later try and maybe apply SimPEG and see if we can reproduce that result, because the data will be freely available.
Might be interesting. A lot of the few stuff that was done time domain in marine CSCM is usually done the same. So it's a continuous source signal, but it's not a wave. So it's a more complicated source signal, and it's then binned and done into time windows and used as time domain data, but it's also measured. Well, there's not an on and off time, it's always on, and you measure at the same time. So there might be similar strategies to use.
Yeah, and I guess I'm finding that I would want to try and invert kind of the anomalous data and not the total field data for various reasons.
Isn't it like what they provide, Devin? I think, as far as I understand, they do remove the primary field, and I think that's their. I think it's one of the important steps on their end, I guess. Is that right?
Process the data, you have to.
They provide you with basically like well, depending on how you feel like representing the data, it's either dB/dt for this highly regulated triangular waveform, or B for a step, and the conversion is basically a constant. And then the way that you would represent the data is that you would either through the latest time channel, which, assuming all the inductive effects have diffused, is kind of a good approximation for the primary field. When you represent the data, you normalize by the primary field, essentially, to try and see what kind of anomalous structures are there. So I'm not sure if there is a standard, I've only really played with this one data set, but I have been given effectively this total field data. I've just been given what was measured by the receivers, and it includes the primary.
Okay, so your data is total field at this point.
Yeah.
And that's what they provide.
Sure, but they've also given me a fairly, they've taken a bunch of data points to really define the path of the transmitter loop. So you can just kind of do a Biot-Savart and remove that, ideally. And I've done that to look at the data, and that seems to remove the primary fairly well. So, I mean, the strategy that I'm looking forward to doing is removing that primary field and then inverting the anomalous data, but then we need to make some modifications to the code so that we can invert the anomalous instead of the total field. Because right now the codes, the Fortran codes, are set up really for airborne surveys where your data are during the off time, and you don't encounter this.
Let's see. It's interesting. And yeah. What they what they actually do. Like that's what you did. What's that company? Like a Lamontage. I think geophysics.
Yeah, La Montagne. Yeah.
La Montagne. What they actually do. I think they're not inverting, I guess, right? Are they inverting the data?
Well, I haven't seen inversion results for this yet. And I know Scott Napier had a master's or a PhD thesis in like over a decade ago. They played around with this system. But he inverted the total field. Like he inverted all of it. And I mean, a lot of what we're doing right now and what the sponsors are interested in is what is the best approach. So I'm definitely going to try a few things. They want a consistent strategy for this type of data.
I did a project like this with the old company that I worked with. We were doing downhole step response. And yeah, Soggy, that's exactly what you would do is you remove the primary and then they would just put it into Maxwell and they would just model plates with the on time. There wasn't an inversion at the time, but yeah, you remove the primary for sure. That seemed to be pretty standard, but I was kind of reading a lot of stuff from the Lamontaignes guys.
Yeah, I don't know exactly what they're working with, but you just basically, if you are modeling the total field with using these codes, the errors associated with numerically modeling the primary field are larger than the uncertainties on your data. And that buggers everything. So always wanting to try to invert anomalous and not total field. So far, that's my feeling, unless somebody can convince me otherwise. But
I think it's very worthwhile to kind of read a little bit more because, like, then to me, like, what's the point actually, like, measuring on-time data, like a time. The beauty of the time domain, I think, you can actually measure the off-time without the primary field. I think there's some physical reason why they are doing it, and
yeah,
actually understanding that would be actually quite nice.
Well, they want the step response of the Earth. They don't want the dB dt. They don't want the time derivative attributed to the step response, which is a lot of what we're doing with the standard airborne.
Right.
During that, they have this long constant derivative in the primary. So they're getting the step of the B field. That's what they're interested in.
Right. Yeah, exactly. Gotcha.
Yeah.
Gotcha. Interesting. It's interesting because but still what you physically measure is the voltage. So I think it really helps because I think the beauty of B field, I think it's better for conductor, I think, a very strong conductor, I guess. That's my understanding. So if you got very late time gates that you want to measure a signal, like just using the voltage, it'll really suffer from kind of having that very like a late time signals. Whereas the B field, it seems like that was my understanding in general, like you can have lower frequency band using the B field. But here, by kind of like by manipulating the waveform, you're getting the B field. But is it really helps? It seems like a question, like because it's not physically measuring the B field still. Anyway.
Yeah, I mean, I can see it. Like I can see that for synthetic modeling, that over a conductor, that B field is decaying more slowly. So I can actually see that the rate of decay for the induced currents in those conductors happens more slowly. I mean, I haven't published it yet, but I've got I don't know, there's stuff I can show you. Like, I don't want to hijack the meeting here, but yeah, I've made a page that kind of explains this and the anomalies you get from a conductor and why we plot things a certain way, and just, yeah.
Cool.
No worries. Okay. Soggy,
John?
is there anything you've been working on? John?
Nothing particular on the break. I was completely off. Completely playing with my son. Before the break, I made some improvements in the 1D code. So now I'm actually pretty happy with the current version. So it's actually now optimized. So, and it's actually quite faster than, I'm not sure, I haven't really checked the 1-to-1. I think it's a couple times faster. And the memory issue, like I had a bit of memory issue with the D version, I fixed it. There are a couple of things that I had to deal with the multiprocessing. So it's actually quite optimized now as I tested for bigger clusters, like using mini nodes, and it kind of scales nicely. So one example, let's see if I can share. Oh, hey, Joe, can you let me share?
Yep. There you go.
So one example that I'm currently working on is the seawater intrusion, the coastal airborne data, quite a coastal area. So yeah, it's a relatively large, like a typical size of about 1,000 line kilometer. And it takes about like a couple of hours to run with like 10 cores or something like that. And yeah, so I'm like, so this actually what was my first time using the new code for sort of the field scale, large scale AEM version. And it seems like working quite well, at least like gives sort of the same result that I have used before. So I'm pretty happy. And yeah, this is kind of like a typical way, the steps that I do, I invert for smooth and use the different reference model. You can see pretty big differences. The red is the conductor, the intruded seawater. But this part, we got very low confidence, as you can see, because I used like a 0.3 as a reference, or I can use like a 20 ohm meter, for instance, it's freshwater resistivity as a reference. Then you can clearly see where we got kind of very low sensitivity. Anyway. And what's kind of cool about this data, it's a time-lapse data. So we got 2007 data and 19 data. So I am going to kind of like slightly modify the code to can handle the time-lapse inversion. And I had a question to Joe, because like I do need a same functionality that can link two model, and then have a constraint in between, which is basically the same problem in the the joint inversion process, because you got two physical property and I have a constraint getting two models. I want to kind of, in this case, like I can expand that. I've got many times lapse data, like many times, like a 10 time lapse data. I have 10 models that I want to connect through, but I may connect for each two of them. So yeah, I could write on myself, but this is something that I need. So if there is an existing sort of the base class I wanted to use,
Okay.
Anyway.
So you want to make it like measure similar to a model that is not the same physical property, or is just
no, it's the same physical property. It's the same physical property, but set as a different model, because like it's a resistivity at 2017 and resistivity at 2019. So although it's the same physical property, it's different, because like there's a time component. And I think it's potentially what we can develop as a general like a class, like a time-lapse regularization class, because I think the need is getting more and more, because like ERT, for instance, there are many time-lapse data, like a CO2 injection, that types of monitoring issues. So having something simple, like basically putting the flatness or the smoothness in time direction, so that in the easiest case, if the mesh is exactly same, we can readily put I think that we can just use the existing kind of mesh structure to put the time constraint. But sometimes the mesh can be different. That is the case for me. Then we can use some sort of different way, like I use the tree, KD tree, to find the closest cell in between times, and then just put the smoothness on that direction, something like that. So that's kind of something that I want to that I need and I want to develop this year. So yeah, but having a base class that I can start with, that would be great.
I mean, the simplest solution for now is just to have multiple reference models and weight them.
Yes, yes. That's something that I could do as well. Yeah, if there's no base class like that, I could just like kind of revamp the existing class and write one.
Yeah, I was trying to dive into that, Joe. Actually, the similarity measure class, and there's no reason why we would only limit to 2, right? The wire map should be like, could be n dimensional, really.
Yeah, it's just that some of them only explicitly support 2 things. Like cross gradient only works between 2, like a pair of models.
Yeah. But then we can put that restriction on the cross gradient class, and the base class it could be. Yeah,
I think it's possible to extend that joint total variation one to multiple. You can probably just keep adding them into the into the square root function at one after the other.
Yeah. That's sort of what I was thinking, Joe, because I basically need the 2 adjacent times. So like you would have
a staggered.
Yeah. So I can just stack over a whole bunch of regularization. Well, in this case, I just only need 2, only 1 linkage. But we got many times, we can just stack over. So I thought that's an okay way to deal with that. So Joe, there is a base class for that that I can use. Is that right?
Yeah, for that similarity measure. Yeah, it's
okay.
Very, very bare bones. But as far as like, okay, I'd want to compare like more of like a structural or kind of like a joint inversion type approach to that to do it.
Okay.
It's called base similarity. Yeah.
Perfect. Yeah. And that is a project that I'm kind of working for the next 3 months. And we're basically constraining the hydrologic modeling, the seawater intrusion modeling using the airborne EM data. So the other item that I am going to update is the 3D airborne EM simulation. So I kind of wrote the local mesh idea, a very specific example for SkyTEM system. But I'm hoping to either bring in or at least update that to be compatible with the existing the current SimPEG structure. So yeah, and at least then we're getting an ability to invert in 1D and then simulate in 3D. Although we have the 3D inversion, but still it's not yet scalable to handle those scale data. So yeah, the kind of my minimal goal is getting solid 1D inversion code for airborne EM and solid 3D simulation code that can handle large scale data.
Sounds good.
Oh, and
Could we?
Oh, go ahead.
No, I was just wondering with the things we do with the large scale EM, if you could try to do this for airborne, but we have to think about it. It's obviously a frequency domain, so we would need like 20 runs to get the time domain, but I don't know how that scales with time. But I think we could maybe once brainstorm if it's possible. Yeah.
I think at this point the easiest way is using for the frequency domain data here, I guess. That is the most easy one. Moving to time domain, I think it'll be quite expensive. So not sure that is the way that we want to go. But in terms of implementation, I think you've got all the ingredients, I guess. You need to just generate many frequency domain response and then transform that into
that's true. You wanted to say something else, Sogi, but I interrupted you.
Yeah, so I made a bit of progress on inverting that deformation data. I have presented like sometime several months ago. So I got the inversion code and it's actually working. Well, kind of working well in a sense. It's let me. So I actually inverted. Let's see.
I think I remember chatting with Iago about this kind of process at one point a long time ago. Is it pretty, I mean, he was saying it was really similar to like all the other types of inversions we do, like potential field types inversions. Or like it's just like the deformation is pretty well related to that. Like they're,
Yeah, I think that's the static deformation. That's a
Yeah.
static case. Whereas what I think for the static case, it's very similar to potential field inversion. It's like it's not even 3D, so it's actually just a 2D inversion. So you assume the physical property, elastic property of the subsurface is constant, and then just invert for the mass like applied to the surface, which is basically the same kind of inversion. Whereas what I was doing is slightly different because there's a time component, and then you need to solve the diffusion equation, and there's some sort of nonlinearity comes in. Let me see if I have one snapshot that I could share. Here we go. So this was actually the talk that I gave in AGU, and this is the INSAR data. So if this red is the big subsidence for 5 years, so it's about like a meter for 5 years, which is crazy. So if you think about the infrastructure like a train, having a 1 meter subsidence, it can kind of
That's huge.
destroy. And there's a canals going on. So it's actually a big risk. So what I did, I just picked a point here, and then I grabbed a whole bunch of INSAR signals and take the mean. It's a proof of concept. So I just take the mean value. And then I got you do need to know the subsurface properties about the clays and what is the storage coefficients and stuff like that. So I assume that I can get I get that information from other literature. So I fixed that. Then this is the data, INSAR data. And the goal is recovering how much water level, like a water pressure, is changing in the subsurface, because that is the main cause in this case. So that is the observed data, and that is my initial guess. And I solved the PDE, and I derived the sensitivity function required to so sensitivity function is the changes in head is the model, the data is that subsurface information. And that's what I was able to recover. So I fit the data, and this part is actually important. The data is not only affected by this point, but the historical head changes actually affecting the data in future. So somehow you need to estimate this. You need the good rate, the linear rate. But once you got okay rate, I was able to fit the data well. And here's my pitch. So if you actually compare with the actually measured data close by, and that's what you get. So this is the actually measured head and how the measured head is changing. And this red is where you got the drought period. So if you think about the drought period, head is going down. So that's the problem, for groundwater management. Head is going down, water level going down is a problem in general. And after the drought, it kind of slowly recovers and oscillate. You can see kind of the good trend. This goes down, goes up, goes down, goes up. And the measured data only have a sparse point, whereas the measured INSAR data have a much better time sampling. So the recovered head that we can get has a much better temporal resolution. And what will be really cool is expanding that into the entire Central Valley, like here. So then you can actually monitor the head changes in the entire Central Valley with high spatial resolution, which will be absolutely challenging yet, because there are other remaining challenges. But I was relatively happy with what we were able to get. And the implementation wasn't too hard with the existing SimPEG structure, and especially for discretized So anyway,
Wow.
that's,
Really cool story, man. Can you come back? Shit. It almost looked like it's the perfect case of aliasing, right? Where you don't say, like their head measurements were too sparse and then you're missing all the high frequency, you know?
yeah, exactly.
Yeah.
So yeah, that is exactly the case. That so
They only put
if
the
you-
peaks and they
Yeah,
miss the
so-
middle.
yeah, look at here. Look at here.
Yeah,
So it
yeah.
goes down and up, but you only pick the peak. So they only got 2 per samples, which is odd, but that is the case.
It's pretty cool. Hey, so, but Sag, if you, instead of that, so you know, before your observation, you just use like a linear thing. If you kind of approximate the measurements with a curve, do you
Exactly.
improve? Do you improve it? Do you improve your model?
I think so. I think so. But what I
Yeah.
was hoping, like kind of the sort of the assumption that I made was kind of similar to the time domain EM, although your Ollie time was like a slightly wrong in the simulation process. What's actually the good property of this kind of implicit time modeling? You get better as you go time by. So even if you got like a very poor time sampling at the Ollie time, the late time, as you go late time, the property gets better and the actual simulated result is not bad.
Okay.
So that is something that
It's
I'm
encouraging. Yeah.
hoping, because the existing data will be dependent upon the entire history. And then
Yeah. If you don't have it, you don't have it.
yeah, it's a full time history. It's not just 1 year ago. It's like hundreds of years. So, but that impact is getting reduced as time goes by, and then the inversion process likely can find an effective like a time history in a way. And then there are many wells. So not only like we have some data that I can interpolate over that I can start from. So in the end, we're going to invert all of them together. So the measured head data will be an additional data that can be put into the regularization function.
Oh
So,
yeah, that will pin your, of course.
exactly.
Yeah.
Exactly.
Yeah,
There are many other information that I need to integrate into the inversion process when I'm upscaling into like a valley scale or the regional scale. So that's the
But
remaining
blindly, you're
challenge.
still doing great. Yeah.
Yes,
I
yes,
get it.
that was my kind of pitch. Okay, even though we don't have
Wow.
much information, you're doing an okay job.
You'll
Anyway.
be a superhero in the hydrogeological world.
Well, I'm not sure. I'm having fun, so
That's good. All right, I should probably get going.
Yeah, I'll call
guys.
that a meeting. Again, if you have a thought about what you guys would like to tackle in the next year, we can chat about it soon.
Yeah. Sounds good.
Take care. See you all later. Happy day after your birthday, Tom.
Oh yeah, thanks. Ciao, ciao.